Hey everyone, welcome to my channel. Let's continue our discussion. Let's continue our learning with AI for Spark. I'm sharing. So today we're gonna learn the advanced concepts of Spark. Mm, so let's continue with our learning journey. So I'll start with. I'll say that let's continue as per the above order in detail. Okay. Uh, so please subscribe to my channel, and of course, please watch my videos in 1.5x speed because somehow GPT is slow as well. And um, yeah, so let's continue with the advanced joins. I think joins we already know. We learned few different types of joins and how to join and what is the join type differences and null handling in the joins and all those other stuff we already had in our previous learning sessions. And now we'll continue with the advanced sessions. Like we'll build this step by step. Okay, yeah. So, what is the data skew? Some keys have much more data than others. Like, okay, so for example, ID is equals to A has 1 million rows and 10 rows and 5 rows. So, when joining, partition with A becomes huge, of course, obviously, because 1 million records are there. So, it will take a lot of time. So, it will become a little complex. So yeah, so one executor gets overloaded, others stay idle. Okay, result job will become slow, of course. So key problem: uneven data distribution, uneven workload. Obviously, this is the pattern where we observe things. So now think if one partition is very large, will Spark finish fast or slow? Obviously, it will be slow. Mm, Obviously, it will be slow, but how to handle this? I think yeah, GPT may have good idea. So let's learn that with the help of GPT. So okay, yeah, Spark job completes only when slowest task finishes. Skew. One partition is huge, one task is slow, entire job slow. Obviously, this is the pattern we were discussing about. Now let's fix skew. Core interview topic. Technique one, broadcast giant. Of course, you already know. I mean, like yeah, we already know that broadcast. If it's small chunk of a, mm, you need to join small chunk of a data set. So in that case, the data set will be broadcasted. Means it will be copied directly to each partition so that the join will become faster. So that is the reason. Mm, so works if one table is small, avoid shuffle. Of course, obviously avoid shuffle because uh, yeah, of course it will. Next, salting. Salting means both tables are large. Skew exists on join key. Idea of salting: break heavy key into multiple smaller keys. Okay, so instead of A1 partition, A1, A2, A3, A4 spread across partitions. So how it works? So add random number to skewed key left side, duplicate right side with same range. Join on key plus salt. How to pronounce this? Hmm. Okay, somehow it is not coming. Let's see. Hmm. To do that, I'm not sure. Let's see English pronunciation audio. Okay, salt only. Okay, fine. Uh, so yeah. Add random number to skewed key left side. Duplicate right side with same range. Join on key plus salt. It's completely confusing, but yeah, let's see. Add salt to left table. For example, if it is a left table with column salt, floor into 5. So what happens? Expand right table. Okay. Salt. Explode array. Literal I for I in range 5 means 5 times 5. Um, 5 partitions it can say, like 5 different partitions it can say. Next, join salt id comma salt. Okay, so then what? Breaking hot key into smaller chunks, distributing load across executors. But for this also we need to have an idea about that table is little huge, and if it happens in the internal transformations, like for example you creating a data frame where you don't know the initial size of it. Mm, and maybe the conditionalized salt, maybe we need to differentiate, define, so we are not sure. Your turn. No, explain. I'll I instead of, okay, why do we need to duplicate df2 right table in salting? I don't have an idea, no idea. Explain this concept with an example. So since, see, if you observe this, maybe I'm not sure about you guys, but I'm not able to get it exactly. uh, so how to break this, I'm not sure. Mm, so let's read one more time. Now let's fix skew. Core interview topic, of course. I mean, broadcast giant, very technique one is broadcast giant. It's obviously if it is a small table where we want a huge table to join with a small table, obviously. Yeah, obviously you can do that. Next, technique two, salting. Okay, both tables are large. Skew exists on join key. Break heavy key into multiple smaller keys. Okay, so I understood that there is a partition you need to, since one partition has huge amount, yeah, huge amount of data in one partition, and obviously other partitions execute and complete the task, but this partition will run a number of time, a number of, it will take a number of time to a number of minutes to complete. So if those, in those cases, that particular big partition need to be distributed into small partitions. That is the idea. I got the idea now. Now, how it works? Okay, add random number to skewed key. For example, I added 1, 2, 3, 4, 5. Okay, so duplicate right side with same range. Right side means the one which you gonna join with a table. Join on key plus salt. So instead of key, you need to take key plus salt. That I understood. That also I understood. Okay, now example. Add salt to left table. For example, df1, df2 is also there. So left table salt, floor into 5. Floor of rand means random table, random value, it seems random value into 5. Okay, next tf2 explode, explode array literal for I in range 5. I, where is I here for I? Explode, I don't know about explode. I think I need to get an explanation about explode as well. Df1 dot join. Okay, id comma salt, these are the two keys. Of course, default join is inner join. Obviously, it will take directly. Next, key intuition is breaking hotkey into smaller chunks, broadcasting load across executors, distributing load across executors, breaking hotkey into smaller chunks. Okay, I okay, I did. Why do we need to duplicate df2? Great, this is exactly the right place to pause and really understand. Salting clicks only with a clear example, not theory, of course. So, for example, df1 is a big plus skewed. A, and B, C. Of course, it has some values. Many rows for A. Okay, normal. df2 is normal. A, B, C is the ID is the key, and P, Q, R is one thing. That what happens in normal job. A rows, same partition. It will be heavy. Of course, that partition becomes slow. Now salting solution. Salting solution will add extra key. Okay, for example, it is added A. It'll add one, okay, for each group, and then based on the key it will group, and it will add one extra key, 0, 1, 2, 3, and again it will start with 0 for this, and it is 1 here. C will go to different chunk, but still it is here. It's a confusion. Now A is split across partitions. Okay, why duplicate df2? We transform df2 like this. Okay, what is this? For example, A df1 is the above one and the df2 is the normal one. The normal one only it says, right? I mean, why it is okay, fine. We transform df2 like this. Okay, A. Now df2 has all salt combinations. So how to know the salt combination here, from the other table or from the same table? For example, AP was there, like AP, BQ, CR. Okay, for the same AP0, each salt gate has to be differentiated. It has to be distributed like this. The same value is same. So you are preparing based on the salt key in the primary table. In the same way, you are defining this. Join on ID comma salt, of course, obviously. A0 joins A0. A1 joins A1. Work is distributed across partitions, of course. Core answer to your question, why duplicate DF2? Each salting key in DF1 must find a matching row in DF2. That is the reason you just, since the salting is happening in the primary table, of course, the table that is joining, which is DF2 here, that needs to be modified with the combinations of the salting key itself. So each row will be, then it will, okay, it will increase the data size, right? Okay, don't know how to understand this. Okay, let's see. Join would fail, miss. Okay. Left side split data, right side replicate data, obviously. Okay, quick check important. Add salt only to DF1, do not duplicate DF2. What will happen to join? Join will not find the matching records from the DF2. Oh, it is taking a lot of time. Join will not find the matching record from the table too. So this is the right thing. So uh, let's give the answer and we'll see. I think it is correct only. But here we need to understand one thing is it is setting up a combination by duplicating the the data frame which primary table is going to join. Exactly correct. Okay, refine answer. Join will mismatches because salted keys won't exist in the DF2. That's the reason we are duplicating. So why crystal clear? Okay. We if df1 has a comma 1 but df2 has a comma 0, then a comma 1 will not match with a comma 2. That's the same explanation it is given. Core takeaway: salting changes the join key, so both sides must follow the same pattern. Yeah, of course, but you need to define, we need to understand the data before the join itself, like what is the main table and the joining table. And it needs to be small, and of course it needs to be replicated before salting itself. But the code snippet I may need to practice a little more on those lines, like I mean exact code. uh, I think we'll do the scenario, one scenario end to end, so that we can identify how that salting will work. Okay, final mental model very important is add salt to df1, split heavy case, distribute load, duplicate df2, cover all salt values, ensure matches. Means highest. That replication blindly happen, how it will happen, that replication, that is the big confusion I have. But yeah, maybe going forward we may need to understand. We may need to learn more. Uh, when when would you not use salting? When there is a skew, when there is skew based on when skew is there uh, based on data size for each key, then no need of salting. I answered it, but I think it may correct a bit. It GPT may correct this. So let's see. Okay, correct answer. You do not use salting when there is no skew. Okay, no skew at all. Okay, why? Salting is only needed when one few keys have huge imbalance. If data is evenly distributed, salting will add unnecessary duplication, increase data size. Fix your statement. When skew is there, no need to salting. When there is no skew, when there is no skew, data is evenly distributed, salting is not needed. Obviously, salting is not needed. Additional important case is you also avoid salting when one table is small, and of course broadcast directly we can do. Data volume is small, of course. Data small volume is small, even though it is slow or use it won't make any difference. It will quickly finish. Only for skew plus large data plus shuffle join. Okay, salting that see GPT is giving this memory rule, like this is pretty good when in all those cases when we are dealing with joints as well at that time. It gave uh, a precise way of differentiating between each joint type. That is the best quality it has. So yeah, salting only for skew plus large data plus shuffle join is there, then only we need to use salting. Small table plus large table plus skew, large table plus large table skew. Which one? Two, obviously. Two, as one can be done with broadcast and so I just answered in a very simple manner, but let's see. Case 2, large plus large, okay, cannot broadcast, shuffle will be heavy and skew will cause imbalance. Salting and its distribution load. Case 1, avoid shuffle entirely, of course, obviously. You now understood skew handling. This is advanced level. Next, join optimization. Very important is like broadcast join, recap plus deeper when you repartition before join. Okay, bucketing, avoid unnecessary columns, obviously. Filter before join and interview summary. And okay, now let's learn this. So till now is okay. Next join. Okay, I'm still need to understand one thing. Uh, I'll ask a question, of course, at the end of this particular conversation. Just a minute, I'll ask that question. But before that, let's continue this and join optimization. Next is join optimization, very important. Broadcast join, recap is deeper, and one table is small and avoid shuffle. Of course, obviously, broadcast can happen when keys are uneven. This I don't understand. I'll ask this question. What do you mean by keys are uneven? I need to ask that question. Next is okay. I'll type that question. So before the question, I have few questions. Let's. I have few questions. Let's type it in a proper way so that it can understand. One is one. Okay, let's go step by step. Repartition before join. What's meant what's meant by keys are uneven? Okay, this is one. And what else here is so repartition, better distribution. Okay, reduce queue impact. How repartition will impact this? As how repartition will impact as partition partition happen partition happen on key basis. It's really slow. On key based. Okay, this is one question. And next bucketing. uh, Pre-partition data on disk. I just don't know anything about it. What is bucketing? I know Hive buckets, Hive large pipelines. I know avoid shuffle during join if both tables are bucketed same way. Okay. Avoid unnecessary columns. Obviously, this is we already learned. I mean, when consider the data which is needed for your computation, so that it will be very clear and it will be very precise, so that debug everything will be easy after that. Uh, Development and debugging later, and results also in a better way. So this is better actually. Filter before join. Okay. Reduce data. Of course, obviously filter. Uh, After join, if you need to filter anything, just do it before itself. After joining, if you filter unnecessarily, it'll strain the system, and of course, any which way we need to filter them. So try to filter before itself. Next is going towards interview summary. So what is that? using data, avoiding shuffle, distributing workload. Obviously, these are the concepts we learned just now. So your scenarios: which what joint strategy will you use and why? One or two lines. Be precise. Okay. DF1 1 TB. DF2 is 5 MB. Obviously, the answer for the question is broadcast. I'll broadcast this DF2 and I'll broadcast DF2. That's it. Very precise answer I gave. So let's see. Uh, yeah, since it is a learning session, it may take time, but you need to have patience. Uh, my my intention is not to create some videos and to unnecessarily waste your time. My intention is to you can follow the pattern and learn by yourself. That is the main intention I have. So that's the reason I'm doing it on live. And of course, I mean, I'll be also completely focused on the topic itself, so that I have to avoid that. I can avoid the deviations. That's why I'm doing YouTube lives. That is the main motive actually. The learning in a quick passion, also detailed passion and end to end with full focus. Okay. Yeah. So I'm not able to understand one thing here is here the GPT says it to wait, right? I mean whether it is because the system is slow or I give multiple answers. That is the reason I'm not able to understand why it is asking me to wait. Whether the chat, because I am started the chat a few days ago, so I'm keep on continuing the same chat itself. Whether it is yeah, whether it is a huge page, that's why it is analyzing each and everything. I'm not able to understand why it is slow, or else GPT is slow itself. Maybe if you get an idea, just let me know. Next, because DF2 is tiny, of course, obviously. Yeah, what does keys uneven mean? Okay, keys uneven mean it is explaining. Let me see what it will. Okay, our question is so simple. What meant by keys uneven and how repartition will impact as partition happen on key based. So any which way the key will be the same. So how the repartition will help? I just want to understand. Okay, so now A10. Okay, each partition of a key is uneven. That is fine. For to avoid that, we are using sorting and we are distributing. We are doing duplication part in the another data set which is we supposed to join, and we'll match those keys in a particular. We will match those keys in a precise manner. Okay, here key A is much heavier than others. That is called skewed uneven key distributed. Okay, I understood why is that a problem. Of course that will be a problem. I already know about it. I mean like all A rows must go together. One partition gets overloaded. Excuse me. Okay, so even if other tasks come finishes, of course this we already know. How does repartition on ID will help? That's a good question. Okay, even I know. Spark hashes the key and sends rows with same key at the same target partition. 1 minute. Good question. Repartition by key means Spark hashes the key and sends rows with the same key to the same target partition. That helps when data is fairly distributed. rows get spread more periodically. Both tables align better for join, but here is key point: repartition does not fix heavy single key skew. If key A is huge, then all rows for A still go to one partition. Repart Okay, one hot key skew means based on a particular key, the data will go to a single partition that will be huge. So that is one hot key skew, we can say. So salting is the only solution to fix that. But then what is the use of a repartition here? Groups same key together, good for normal joins, bad if one key is extremely heavy. Minimal heavy it can manage, but extremely heavy then you need to do salting only. There is no other way. It's a good understanding. So repartition. Okay, what exactly example of repartition? I'll ask the example of repartition. What exactly it will do? Okay, if ID equals to A has 50 million rows, will repartition alone solve the skew? No. Simple answer is no. I have okay. I have a question. Give me example for repartition. It redistributes data across partitions used for better parallelism, aligning data before joins, controlling partition counts. Example: basic repartition. Initial data, say one partitions, say two partitions. Partition 1 ABC, partition 2 DEF. DF dot repartition 4. Okay, it's changed the parallelism, like depth of the parallelism will be changed. Partition 2, here it is two partitions. If you want to change the depth of the parallelism, then yeah, in simple words, repartition changes the depth of parallelism. This is what understanding I have from the past. Uh, but yeah, I was little confused here, so now I'm clear. Same case go, same partition. So yeah, I think somewhat it will help a repartition. So matching keys already aligned, shuffle becomes more efficient. Important limitation you already understood. If of course 1 million repartition ID all will go to same row only. That the only Way to fix this is salting. That's it. There is no other way. Okay, repartition, increase parallelism. Repartition key. Align data for joins. Salting, of course, fix queue. Next, mini check, very important. Repartition file, repartition ID. Which one will randomly distribute data? One as it distributes into five partitions randomly. That's it. It's not based on ID, so yeah. The second one is obviously on the key basis, so I think it'll. I think this is the correct answer, but I'm not sure. I'm yet to learn this. Mm, correct. Okay. Why? Redistribution data randomly. Only goal create five partitions. No guarantee about key grouping, obviously. So when there is no key specification is not there, then yeah, I think the distribution can happen in that way, but it will also create some shuffle. I don't know why it is. Okay, let's see. Contrast important is ID has, of course, it has specific key, and of course same key go to the same partition. Random spread, group by key, something like that. Yeah. Next, performance tuning, very important. We'll go step by step. Concept narrow and wide transformations is obviously we know. Narrow transformation, no shuffle, data stays in same partition, obviously. Wide transformation causes shuffle, data moves across nodes. That's little complex. Yeah. Why this matter? Wide transformation equals to performance bottleneck, obviously. Obviously this is correct. When the transformation is wider, then all things little complicated, like getting partitions, processing them, joining, or any other complex transformations. If you want to debug also, if you have a wide transformation, you have to debug in a very careful manner. That's also pretty important to understand. Which one is more expensive and why? Filter age is greater than 30, group by DEPT count. Grouping is expensive. I typed my answer, but it's not showing up. I don't know why. Let's see. Oh my god, it's too much slow. Grouping is expensive. Yeah, I wantedly. Yeah, I did some spelling mistakes, but yeah, I'm just waiting for the results from the chat GPT, like whether it answers perfectly or not. Let's see. Yeah, it says correct. Grouping is more expensive. Of course, why? Yeah, we already know. Okay, let's tell that grouping is expensive because wide transformation requires shuffle, and all same keys must go through must be brought together later by shuffling. And of course, it won't be having any shuffle. Next is clean. Clean answer you should say in interview. Grouping is more expensive because it triggers shuffle, and while filter is a narrow transformation and runs within partition without data movement. Okay, that's pretty good, but wording's not forming in a well manner, so I need to improve my articulation skills. Okay, so next concept, cache and persistent, very important. Okay. Hmm. I need Spark recomputes data again and again due to lazy evaluation, of course. Yeah, due to lazy evaluation. Okay, count show. That's fine. Filter runs twice. Without cache. Okay, count. Okay, that's perfect. Okay, now df2 cache. If I cache that particular data set, now computed once reused. Yeah. So it's a concept of reusability where an action called for each time in if you don't persist or cache that particular data, whatever the data frame you have uh, created, you need to persist, otherwise it will do this filter, whatever the filter condition it is specified here, it will perform multiple times, one for count and one for show. So which is very bad. So I think that's the reason we persist our cache. But the only thing is it will store in memory. That's the problem. I need to understand a little more. Let's see. So yeah, reuse cost. Think in terms of reuse and cost. Okay, and that is the thing we need to use. Okay. I think reuse. I can only think of reuse as of now, and it is expensive. Obviously, it is expensive because it will utilize the memory. Whenever you utilize the memory or disk, right, it's obvious that it will be expensive. And shuffle also it's expensive, and joins are little expensive. Grouping things are little expensive. So yeah, uh, when we really want to reuse and cost is not a matter. In those cases we'll use I thought of using a voice mode, but it is taking a lot of time. Come on, okay, good, but let's refine the precise and correct. Okay. Correct answer, use data frame when a data frame is used multiple times and it is expensive to recompute. Okay, the cost is whatever it is saying is it's expensive to recompute. Okay, if it is a complex transformation and an action and followed by an action, so in those cases, so you don't want to do it again. So that okay, oh, that is not correct. Okay, cache uses memory, so cost does matter. Yeah. So better way to say is use cache when recomputation cost is high and the data frame will be reused multiple times and memory can handle it. Okay, that's a good answer. Next is reuse plus expensive competition is equals to cache. Okay. One time use, don't cache. Memory tight, don't cache. You have a memory and and it is reusable and expensive competition is there inside it, then use cache. Okay. Will this benefit from caching? No, it won't. As it is a simple as it is a simple as it is a narrow. I think as it is a narrow transform. That's what I'm gonna answer, but let's see. I'm thinking that it may say I am wrong because count. No, I'm still confused. Let's see. Let's see what it will answer. Good reasoning direction, but that's not the correct reason. Okay, no, caching won't help here. Huh? Will this benefit from caching? Okay, it says count. Yes or no? No, caching won't help you. That's what I said. No, as it is an arrow transform. Okay, caching won't help here because the data frame is used only once. No reuse, no benefit from caching. Of course, that's what I said. But yeah, there is a articulation issue I have, so that is a problem. So I need to improve that line. Okay, because it is an error transformation. That's not deciding factor. Of course, whether it is a what type of transformation is doesn't really matter anymore. My intention was to that it's not a cost of it won't consume that much cost. So yeah, that's fine. Even if it were a wide transformation, caching still couldn't help it. It's because only once. Hmm. Right way to think caching depends on reuse frequency, recomputation cost. Reuse frequency, man, single one. Okay. Cache only if reuse frequency and recomputation cost is matter, then only you use it. Okay. Quick test. DF group by DEPT count show write save output. Okay. Will caching help? Yes. Write dot save. It is writing it to disk, right? So once it is writing it to disk, I don't think we need to. I think no. As data saving to disk with dot save. Let's see. I'm thinking in those lines, but I'm not sure. Let's see. Count dot cache. Yes, okay. Got it. Okay, the code after this group by and dot count and of course dot cache it will automatically cache save time. Okay. Important correction to your thinking that does not Prevent recomputation. Spark will recompute unless cached. Okay, final rule. If a costly data frame is reused across multiple actions, then cache it. Okay, next. Last concept in tuning is repartitioning versus coil is very important. Quick intro. Repartition, increase slash decrease partitions. Coil is reduce partitions, no shuffle. It's a little faster. Coil is so when which one is better for reducing partitions from 100 partitions from 1000 to 10? Coil is will always not repartition. 2 as there won't be shuffle if I use coeli. And come on, it's taking a lot of time. Okay, so correct. Coalesce is better for reducing partitions because it avoids full shuffle, merges existing partitions, cheaper than repartition. Coalesce is a great when reducing partitions. You do not need perfect rebalance. Yeah, repartition is better when increasing partitions, or you need even distribution. Small ones is. Coalesce is great when reducing partitions. You do not need perfect rebalance. You need not to worry about rebalance. Then, just to reduce partitions, then you can use coalesce. Of course, it won't shuffle. It won't do full shuffle. Uh, and repartition is better when increasing partitions, or you need even distribution. The load is the important aspect here to understand this. Quick comparison: coalesce 10 reduces cheaply, repartition 10 reduces evenly but shuffle costs. Right. Mini check. If you want to go from 10 to 100 partitions, I'll do repartition. Repartition as to increase partitions. So I'm answering in a very lighter manner. I'm not sure whether GPT will like it, but okay. The recap for to move on next is what we learn about skew and salting, repartition by count versus by key, narrow versus wide transformations, and when caching helps and repartition coil is there. That's a very good learning in this session. So Let's continue with the next session, which is a very important structured streaming. So that's a very nice concept to understand. So let's continue with that later. Yeah, thanks for watching my live, and yeah, let's meet again. Please try to subscribe. Thank you.